Hey everybody, this is Mr. Storm, and in this lecture, in this video, we're going to talk about computer networks. We're going to talk about what they are, why we use them, and why they're so dang important. There we go. Okay, so learning objectives, I'm kind of covering up a little bit of them, but I'll read them out loud to you. We want to understand and evaluate different networks and how they transmit different types of data. We're going to understand and identify the roles of clients and servers in a network. We're going to understand the fundamental principles of security in regards to networks. We're going to demonstrate an understanding of network speeds, wireless communication, firewalls, and gateways. We're going to do all that in this briefing. So what is a network? Well, a network is essentially a group of computers. They share information through their interconnections. So if I take computer A and I have computer B and I hook them together with a cable or with a wireless signal, then I've created a computer network. It's really just two or more computers connected together so that they can share information. A network is made up of the following components. One, you have the computer systems, the nodes or the hosts, whatever computers are going to be on your network. Then you have network devices that transfer that data from one computer to the next. You have the transmission medium, which is how does the signal get from one computer to the next? That's usually through cables or through a wireless signal like Wi-Fi. And then you have protocols, which are rules that dictate how that data transfers, right? So we need something that kind of controls this whole thing. Now, out of all four of these, only one of them doesn't actually exist in the real world, right? Computers, they're real physical things that we can touch. Network devices, those are real physical things. The transmission medium, that's a real physical thing that we can pick up and touch. I can lasso you with a network cable or whatever, right? But the protocols, these are just rules written into the networking hardware that dictate how data gets moved back and forth. The protocols aren't something you can pick up and play with, right? They're just kind of software and programming inside the network hardware. Okay, so let's talk about the different kinds of networks that exist. A LAN, or local area network, is a network in a small geographical area. So back when I was, in my more nerdy days, yes, I was more nerdy than I am today. Actually, I don't know, I'm pretty nerdy all the time. Anyway, back in my younger days, we used to hook up a bunch of computers together, me and friends of mine. We would hook up our computers together and we would play video games against each other in a local area network. That is a network that's not connected to the internet. It's just a bunch of computers together, hooked together in a small geographic location. A wide area network is a group of LANs, or local networks, that are geographically isolated but connected to form a large network. So something like the internet would be a wide area network. The internet is just a series of smaller networks all connected together into this one big global wide network, okay? Then we have metropolitan area networks. These are usually networks that just span an entire city. Or you have personal area networks, which are in very, very small networks, usually just communicating from one computer to another between personal devices. So in my house, I have a personal area network for some of the devices that I want to be connected. I have a connection to my printer. I have a connection to other devices that I have connected to my computer. So personal area networks are smaller locations, smaller areas. Clients and servers. So think about a network kind of like, I'm going to use a lot of metaphors today, by the way, because networking is kind of hard to think about unless we kind of give it a metaphor. Think about networks like you're eating at a restaurant. So if I'm a computer, right, and I'm sitting at the restaurant and I need some data, I need some food brought to me by, I need some food to eat, right? The food is the data, right? I am the client, right? I'm the one who's being served. Then I will have a special computer called the server bring me that data, okay? So clients are computers on a network that accept data. Servers are other computers on the network that provide a service to the client, right? They either give them some files, some data, or they give them an application that they can use, or yada yada. There's tons of services that a server can provide. So if you hear the word server in context of computer networking, it's really just a special computer that provides services on a network. So let's talk about the three most commonly used network hardware objects. So the first is a hub. A hub is essentially just a central connection for multiple devices. Just a little box. You plug a cable into it, and then you plug other cables into it, and those cables go to different computers, right? So my box, my hub, will bring in signals on one port, and then we'll route those signals out on all the other ports, right? So it's a quick way for us to set up a computer network just by plugging all of our computers into one box. All right. A switch is the same thing as a hub, but it decides where that signal is going to go. For example, if I have a 5-port switch, right, and I have some information coming in on port 1, and I want that information to go to port 5. If I'm on a hub, then it'll just send it to it'll take that information and send it to ports 1, 2, 3, 4, and 5. And then 5 is the only one who needs it, so 5 says, thank you, I've got that, thank you very much. Everybody else ignores it. On a switch, however, it's a bit more secure and efficient because that comes in on port 1, it gets routed specifically to port 5, no one else sees the information. That's the only difference between a switch and a router, or a switch and a hub. Switches work by using something called a MAC address. All right, the MAC address is something that is stamped onto your network card of your computer. Every network card has a different MAC address. So when I send a signal to a specific computer on a switch, I'm sending it to that MAC address and only that MAC address. All right. Then the third is a router. A router will connect two separate networks together, right? So a router can take, it can take your home network and connect it to the World Wide Web, or the internet, right? Which we'll learn next week. The internet and World Wide Web are actually two different things, but it will take your home network and connect it to the internet. Much like at the school has a series of switches. There are some in my classroom that are all connected to a router. The router will take those networks that are all being used, or those networks that are all configured by switches, and connect those networks to the internet. Security. There are tons of security concerns with networks, so let's talk about some scenarios and see if we can figure out what the security risk is for each. So let's say we have two LANs are connected into a WAN configuration using a cable stretched between two buildings. Well, what could be the issue there? Well, that cable being stretched between the two buildings is vulnerable for someone to come in, cut the cable, put an end on one, put an end on the other, plug both into a device that's capturing all the network traffic between both networks. Okay, so that's a security risk. We want to make sure that we are that we are burying cables and making sure that we're not leaving ourselves open for attack. Let's look at this scenario. A network is created on a LAN configuration for a doctor's office. Patient data is passed from the doctor's computer to the receptionist over a hub. A port on the hub is open. The hub is sitting in an unlocked closet by the patient rooms. Well, if you think about it, and you remember back to the last slide when we talked about hubs, remember that hubs will send out the data on all of the ports of that hub. So if we have an open port on that hub, I can walk into the unlocked closet, plug my computer into that hub, and capture all the data coming into that network. And since it's the doctor's office, that's especially gross because then I can get everyone's, medical records and stuff. A computer classroom has a 16-port switch in the middle of a couple of desks. Only half of the ports are used, the others are open. Well, this could be an issue because I could plug into the switch and I can install any kinds of viruses and gross stuff I want onto the computer. Now, if you're thinking, hey, Mr. Storm, your room has a switch that has a bunch of ports open on it, maybe I should install some virus on your switch. I've disabled all the ports we're not using. So I'm thinking ahead. All right, let's talk about firewalls. Firewalls are essentially a device or software that basically runs in between your computers and the overall network. And it blocks network traffic that you indicate that you don't want, right? So you set up the rules, and the rules will say, I don't want network traffic that contains this kind of data, and then it keeps it from getting to your computer. It's a way for us to block out anything that we see as inappropriate, anything that we see as maybe this might be a virus or whatever. We can block specific data, and we can block data from specific places using a firewall. Wireless networks. Wireless networks are really how mostly, this is the big deal. This is how we're really connecting networks these days. And really all it means is we're replacing that cable, the Cat5 cable, with a wireless connection. Whenever you connect to Wi-Fi, you're connecting to a wireless network, right? Network speeds. Network speeds vary greatly depending on a ton of things, right? What network devices are you using? How far away from you are you from the thing you're trying to connect to? Is it wireless or wired? Those are different. How much bandwidth do you get? Bandwidth is the amount of allowable data that can be sent on a network at any given time, right? So if your internet service provider only allows for a very narrow bandwidth, then your speeds are going to be very slow because you can only pass a certain amount of data, bits per second. You can only pass a certain amount of data every second or so, right? So the more bandwidth you have, the faster you can pass information on a network. Other things that can affect your network speeds are wireless hardware. Wireless tends to be slower than wired connections, although that is kind of changing. We're getting some really good wireless technology these days, especially 5G. Once 5G comes on, it's supposed to be just as fast as a wired connection, so that'll be great. Other devices on the network, maybe we have a lot of devices passing a lot of data, eating up a lot of that bandwidth. The cables that you use, maybe you're using improperly shielded cables or poorly constructed cables. Your computer itself, maybe your computer is just not connecting fast enough. Maybe the network card on your computer is kind of old and doesn't work very well. So there are a lot of things that can affect your network speeds. And that is it. All right. If you have any questions about this stuff, please let me know. This was only barely scratching the surface on networking. We could have gotten into a lot more detail, but we didn't, because this is an entry-level class and you don't need to know too much about networks. I just need you to know what they are and generally how they work. All right. See ya.